Oh, and there we go. I think I should be live now. Are the slides live? Ru, can you see the slides? Yeah, marvelous. Thank you. Hello, everybody. I'm not going to be able to respond directly, but I understand that that Ru is keeping an eye on the comments. So please feel free to leave any feedback there, any questions, any silly comments. I'm also on Twitter, so at @MadSimonJ. So please also feel free to reach out to me there if you have no other means. I like feedback and a bit of banter where possible. I understand we have some technical limitations today. So I'd also take a chance to admire Andy Green's artwork that he did for my for the front of my slides. Isn't it nice? I'd like to claim credit, but it was all Andy's work. Right, let's get it going. Little brief bit about me. I'm not going to dwell too much, but I've been in the IT business for about 16, 17 years now. I've worked for an awful lot of different places. I've done different styles of retail across the UK, government and manufacturing, and various other things. I was briefly one of those contractors your mum used to warn you about. And these days, I work for Müller Dairies. I don't know whether they're well known in whichever country you happen to be in at the moment, but certainly in Germany and the UK, they're fairly well known. In Germany for milk, and in the UK for a brand of rather delicious yogurt. And that's my Twitter handle. It's at @MadSimonJ, in case anyone wants to reach out to me there. I am available. So, moving on to the purpose of this talk. This, according to me, is the great conflict of our times. We've got two men here, and one is pretending to be a teenager but fooling absolutely nobody. And one is straight-laced and serious and always works hard. The other is the slacker, the one who takes it easy. And of these two gentlemen, which is the one who had more fun doing what they do? Only one of these folks got to ride around in a flying time machine and almost sleep with his. No, don't do that one. But I would argue that taking it easy equals an awful lot more fun at work. And I don't mean not delivering on the things you're supposed to be doing, because we must do that. That is our job at the end of the day. But I like to try and find ways to do it as easily and with as little effort as possible. So then you can go back to taking it easy a bit. And this is kind of what this talk is about. These are a collection of my thoughts and ideas and tips for ways to accomplish the same amount of work, but with less effort. So these, again, according to me, are the stages of a project. Now, I'm a developer, so this is a developer-oriented talk. And as a developer, which of these can we make an impact on with regards to the amount of time taken on a project? Well, gathering requirements would be down presumably to a BA. And designing a solution, maybe, that depends, but possibly not. Testing, typically the role of the tester, but I appreciate not all companies work the same way. But the two where, as developers, we spend the vast majority of our time is coding and enhancements. And of these, I would argue that the vast majority of our time is in enhancements. Now, if I were in person, I would start asking for a show of hands now to try and get an idea for how old some of the code bases are that folks are working with. Now, I don't know about anyone who's listening, but personally, I have certainly worked on code bases upwards of 15 to 20 years old. That is not inconceivable. It's likely, depending on where you work. And which means that the amount of initial coding effort is a fraction of the life of the application. And so anything that we can do to make it easier to enhance the code base, even if it means a little extra time in the initial coding, long term over the life of the project is going to save colossal amounts of time. So I'll get into some of that later. And what are the reasons also for delays in project? Well, these are three that I came up with. Unclear requirements, well, that's between yourself and whichever DBA you believe in. Project management issues, that's probably an issue for your project manager. And legacy code base, this is a big one. For me, at least, the legacy code base. That is one of the things that drags any relatively simple project into being something that's going to take weeks to months of additional time because it's just hard to work with the code. And the main problem is often, for me, trying to work out what on earth this legacy code's trying to even do. A scenario I've personally been involved in is one where there were, for example, on an input box on a form, 2 rules, and the business wanted a 3rd rule. And I thought, fine, okay, we'll just slide in an extra rule. But then when I dug deep, it turns out that one of those rules was spread between 3 different DLLs. Some of the 2nd rule was actually in stored procedures, and not even stored procedures directly linked to my project, because there were also overnight scheduled tasks which had an impact on that 2nd rule. And the whole thing became an absolute nightmare, trying to work out what the code does, where the code rules are, and where actually to make my enhancements, rather than what my enhancement should even be, which was actually the easy bit. Quite often in those sort of circumstances, your enhancement turns out to be a line or 2. But the hard part is trying to work out exactly where. And this comes about from code, which is fundamentally hard to read. So looking at the parts of a function, these are, in my view, the 4 parts of a function. We've got parameters, which is stuff coming in. We've got return value, which is stuff going out. And in the middle, there's actually 2 ideas. And I would argue that most of the problems we get with our code base come from these 2 things being completely blended together and getting in each other's way. So we've got code structure, which is how we are trying to achieve what we are doing, and the business logic, which is what it is we're actually trying to achieve. And if we can separate these out, if we can get rid of the structure, then the business logic, the what are we actually trying to accomplish, is pushed right up to the front, where we can see it clearly and easily. There's a concept in audio engineering called the signal to noise ratio. So the signal is the thing you are trying to listen to, and the noise is something potentially unpleasant that comes along with it that you don't want to listen to. So on a cassette, the noise is the hissing noise of the background. On a record, it's a rumble. On a Justin Bieber album, it's the album. An unpleasant thing, best minimized and destroyed with fire. So I would argue that the signal in code is the business logic, the what we are trying to achieve, and anything that is not that, anything that's just simply code structure, is noise. And a lot of this talk is about trying to minimize the noise. So first part, we're going to try and go right down to the micro line level. How can we eliminate micro noise? Well, here's a block of code. See if you can work out what that does in 5 seconds. It's not so easy. And there's an awful lot of noise here. There's a lot of repeated structure. Got a lot of if-elses, there's try parses, there's all sorts of other things going on. Now, what this is actually trying to do is to have a look at configuration settings. This is slightly old style .NET. I know there's better ways of doing it now. And it's having a look to see whether a value exists and then parsing it. And if it doesn't exist, applying a default. That's what it's trying to do. But that's a lot of lines of code to do something that's actually relatively simple. And if we ever want to enhance this thing, if we're ever changing adding a new setting, and you're going to have to add 1, 2, 3, 4, 5, about 5 new lines every single time. That's a lot of new lines of code. So what we could do instead is use an extension method. So I've attached this extension method to all strings, and I'm calling it value or default, meaning get the value out of it or else apply a default. And what the default value I'm supplying indicates what type I actually expect. So in the first instance, where I'm trying to get an integer out of it, I'm doing a check against null or white space, and then I'm doing a try parse. And if it's not null or white space and the try parse does work, then we return the parsed value. Otherwise, we return the default. And the second is a simple version, the same thing, but it's just a string. So we're just doing it as null or white space check. Which means that the entirety of that first code sample can now be replaced with this, which is an awful lot simpler. It's quite easy to see what it's doing. It's descriptive. And your non-technical boss could potentially even have a look at this and understand what it's trying to do. They might not understand every detail of exactly what's going on under the surface, but they could look at this and potentially even recognize faults if a parameter name or something like that has been misapplied. Junior members of staff could more easily look after this code base compared to the old one, because they don't really need to know what value or default is doing under the surface, because who cares? It's fine. It works. It's simple, and simple is good. Now, a few commandments regarding extension methods. Extension methods get a bit of a bad rep, but I think extension methods are brilliant, but you have to obey certain criteria to make them worthwhile. And when I say commandments, as always with these things, and as I will probably always say in nearly all questions ever asked to me, it depends what you're trying to do. So take these as my guidelines, but generally speaking, I think if you follow these, you'll end up a lot happier than if you don't. First off, no business logic. Business logic is the most important part of your entire application. That is the part that should be pushed all the way to the front where everybody can see it. It should be nearly the first thing everyone notices when they open any bit of code. It's the most crucial and important part of everything you're doing in this application. So you mustn't put it into an extension method. Extension methods are the equivalent of the snarf action figure from Thundercats that you've been saving ever since the 1980s. And you don't want to get rid of it, but you also don't want anybody to see it. So you just put it in a box and push it into the attic or the loft or whatever, and somewhere where you can forget about it. And that's what extension methods are. It's a convenient way of taking boring code you don't really want to see and pushing it where no one can see it. And business logic does not belong here. Keep them compact. I don't like to put the moment an extension method gets too long, that's when it's starting to smell a little bit like you're putting some sort of business logic into the code. Maybe you aren't, maybe you are, maybe you aren't. That's going to be a value call. But if they're not incredibly compact, that's starting to smell a bit. So be cautious about how exactly how much code you put in these things. I keep them generic, meaning as much as possible, I use a generic T, meaning they can apply to anything in the whole of C#. Sometimes, like with my string example, you have to apply it to a string because it doesn't make sense to go anywhere else. But wherever possible, I use the T, so then they apply to everything, and they are much more reusable that way. Keeping them portable, meaning I maintain extension methods that could potentially be picked up from one project and dropped into nearly any other project in the whole of the world. Once again, referring back to no business logic, they should be handy little helper methods. Use them whenever there is repetitive code. As soon as I've started doing a little bit of code structure more than once, that's the time to start thinking about an extension method. An example, not long ago I did, I was parsing out XML files and doing an awful lot of messing around with turning XML into data classes, and extension methods are good for that sort of thing. And make them finally actually useful. I was told once when I was doing this talk of an extension method at a business where the extension method was called isTrue, and it simply returned true. That is not useful, and I'm not sure why that is there. That's actually obscuring something important. So don't be doing that. And I think, generally speaking, if you follow these guidelines, then you'll find that extension methods are a very powerful tool that you can use to shave out tedious code from your code base. Here's an example of another one that you could potentially include. This is a generic parser. Take a string, take what it is that the line should split on, which is typically a new line, take it what the field should split on, which is typically a comma, but not always, could be a tab. And then this will turn it into an enumerable of strings. So you can easily turn any contents of a CSV into something that you can then process on further from an enumerable of strings. Other examples, empty if null. So check an enumerable, and if it's null, return instead an empty. That saves the need for all those double question marks in a lot of places, and it's actually descriptive. Part of the point of the extension method is what it's doing is descriptive. It tells you in words what it is it's done. And another one there is if it is not null and there's any, then so you get a boolean back based on whether it is null and whether it is not null and whether there's anything in it. Otherwise, if it's null or empty, that would return a false. So we're getting around a null exception by using that method. And a way of handling dictionaries to make them a little bit easier. I like dictionaries. Dictionaries are one of the best features of C#, one of the many best features in recent years. I also love record types and a few other things, but dictionaries are brill. But there's an awful lot of clunkiness surrounding dictionaries that make them just ever so slightly painful to work with. And one of them are things like, let's say that you have key value pairs. Well, it should be immediately obvious how that should transform into a dictionary. You have a key and a value. Well, you could write extension methods for automatically converting those sort of things into dictionaries. Something that if it's a key value pair, then take the key and make that the key, and then the value and make it, well, you know, the value. Same with tuples. If it was a two property tuple, then it's pretty obvious exactly how that should be transformed into a dictionary. So this is just saving ever so slightly on a little bit of tedious, noisy code. Something I use as well occasionally is convert something into count dictionaries, which is do a group by a value and then take the count, and then you could use this to form reports out of the value and the number of times it occurred. So this can potentially save you a bit of effort too. Right, that was micro line noise. So moving on to slightly broader structural noise. We're moving up the chain now. Now, I used to work for an American company many, many years ago, and I am British, as you can probably tell by this accent. I unfortunately does not scrub out, and there is a cliche that British people talk an awful lot about the weather. This is entirely true. We do. The weather is a constant source of surprise to us. In the UK, you can get 4 seasons in a single day, and that's absolutely true. So I would ask the folks in America what the weather was like outside and what the temperature was, and they would say things like it's 100 degrees. I would say 100 degrees, goodness me, that sounds like the boiling point of water. And of course, they're working in Fahrenheit, which is used in the US, and I work in centigrade, which is used everywhere else. And the formula for converting is something along the lines of multiply by 9, divide by 5, and add 32. And in my function, I'm going to also format it nicely into something that looks a bit nicer. I've got an awful lot of, there are a few problems here. Now, I could merge these all onto one great big long line, and that would be fine, although it would be the nastiest, ugliest line you can imagine. And that's not very good for presenting business logic. And if I leave it like this, I've got the problem of I've got all these intermediate variables which are there for a line and then never used again. And that's not great either. And imagine that you do this sort of thing in a gigantic function. I've seen functions thousands of lines long. And if you declare lines like this at the beginning, they're still in scope at the end of the function. And these are numbers, so no big deal. But what if they were complex objects? Well, that's something that's sitting in memory for all this time. So there are ways of dealing with this. There we go. This is called map. Map attaches to a T input. That's a T. It's a generic, so it attaches to everything. And what I require is a func. That's a function stored as a variable, which turns the input, whatever that is, into the output, again, whatever that is. So anything to anything. And then all I do inside the function body is simply do function, pass in this, and transform the old thing into the new thing, which means I can turn it into something like this. Now, map is different to a select. So this is in principle similar to a select, but a select operates on individual elements within an array. Map operates on whatever the entire object is. So if I fed map an enumerable, X inside that instance of map would be an enumerable. So this is map applied to things that aren't enumerables, if you like. And it means I can do a series of operations which look kind of nice and logical in steps, and it removes the need for even a function body in this case. This is a very, very simple example of a functional programming concept called a monad. But there's a bit more to them than this, but this is the super simple, easy version. I'm not talking about that any further. And also, you can, if you wanted to do some debugging, you could pop something like this in. T is a name I typically hear this called. I've heard it called taps as well. I've heard this called a few things, but basically it's a sort of like a wire tap. You get your headphones listening in on the wire, and you can do something with it, but you can't change it. So this is returning the same original input again, but allowing you to perform an action in the middle, which might well be, for example, logging or writing to console or something like that, which means that you can have a series of these map calls doing the transformations. And oh, there's a mistake there. And in the middle, we've got this T, which is saying, okay, in the middle of this, do a log, and then carry on as if nothing ever happened. Here's another example of the sorts of things that a few extension methods can save us from. And okay, I've got a function which I'm calling prepend hello. So it takes a string, and then whoever's name you've just given me, we're going to say hello to them. That's nice, isn't it? Isn't that nice? So first I'll call getPerson666, which is the number of the beast, and we've got a value. So something comes out of this, an actual value with a person, and then we'll try the 616, the other name number of the beast. And that, in this imaginary scenario, because I've made all this up, returns null. Now, if you try calling prepend hello with person2.name, well, that's going to cause a null reference exception. That's no good. The fix for that typically would be stick if statements around it and stuff like that to check for null, and that's marvelous, except that now we have started adding code noise into what should really be a fairly simple set of operations, and I dislike code noise. Look at that. There we go. So we're already making this harder to read by adding in ifs and checks and stuff like that. We've had to separate out the hello one from where it's defined to where it's used. It's adding apparent complexity to something that is actually simple. So this is one method that we've got. You can use some imagination, as often is the case with these things. So I'm going to call it do if not null. So I'll attach it to T1. T1 is anything, it's a generic. And I'll take a function, kind of like the map, which turns T1 into T2, whatever it happens to be, type to type, different types. Now the next line, the equality comparer there, that looks a little scary, but it's just a generic version of a null check. So you can't check against null with a generic, reason being not everything defaults to null. Integers default to 0, Booleans default to false, and so on and so forth. There's a few others as well. So what I'm saying is, if it is not null, if it is not default, whatever default might be, therefore run the function and transform T1 into T2. Otherwise, return default, and that'll be default T2, which will probably be null, but who knows? So if I then amend my code to this, I haven't really added very much, no more than a few characters on, and it's still the same in principle code. It's just that now there is a function inside do if not null, and that is to do the prepend hello. I put a little bit of structure around the prepend hello that does a check before executing. So that null check is now baked into the structure of the do if not null. So we don't need to do it anymore. And we've kept the code relatively simple and made it safe to continue. Okay. Talking again about dictionaries. Now, I do love dictionaries. I love the nice, simple syntax that you can use on a dictionary. I like the fact that it's got a lovely quick lookup, so you can do nice things with the efficiency of algorithms, and that's all marvelous. But one thing I dislike about dictionaries, again, is some of the stuff that goes around them. So I am a big fan of the British TV series Doctor Who. I don't know where everybody's from that's listening at the moment, but Doctor Who, if you've not heard of it, is the best TV series in the whole world. It actually is. Officially, it's in the dictionary. Go and look it up. And the lead actor has been played by upwards of 15 actors and counting. So I've just put the first 5 actors to play the lead character in here, along with an index number. So first actor, William Hartnell, the boss, then Patrick Troughton, and so on and so forth. And I'm going to make a dictionary here, and I'm going to make a function called getDoctor, which is underpinned by a dictionary here. And you pass in an integer saying which actor do you want, which number, and then it'll go to the dictionary and then look it up and return back whatever that string was. So fine. If we put 1 into getDoctor, then it goes to the dictionary looking for index position 1, and that's fine, no problems. Let's say that we stick in 100. Now, there haven't as yet been 100 doctors. There have been roughly 15. What happens there? Well, boom. Something that I really dislike about dictionaries, it throws an exception, an unhandled exception, if you try to find something that's not there. Now, this turns something that should be a lovely, simple device for quickly looking up data into basically like an unexploded bomb. It may explode at any given moment. So are there ways of making this a little bit simpler? Well, let's have a look. I've created an extension method called toLookUpWithDefault. There may be a few ways of doing this, but this works for me. So attach to all dictionaries and return back a func. Now the func has got 2 generics in there, tk, which is the key, tv, which is the value. So a func that turns a key into a value. And then a default value of type vtv, that being whatever the type is. Now, in my case, tk was an integer and tv was a string. And what I'll do is call this, that being the dictionary, .try get value. Now, notice there are actually 2 arrows. There's an arrow at the end of the first line, and then there's another arrow following the x. So this is a function which returns a function. And the second function references the dictionary via the parameters to look up with default, meaning that provided the second function is in scope, it will keep the dictionary in scope. But this is acting as a sort of a gatekeeper, sitting between the dictionary and whatever value you're trying to look up, and stopping invalid values from being passed to the dictionary, so that we can handle upstream any problems that might result in an unhandled exception. So what I'm saying is try get value with x, with that being the key. And if it finds the value, then it will be in value the variable. Otherwise, return the default. The second one is basically the same exact thing, except we'll literally return the default, which will typically be null, but not always. Took me a while to explain, but what it means is that you can now do things like this. So I'll create my dictionary again with the first 5 actors in, and then call toLookUpWithDefault, and I'll make my default don't know, which means that if you call getDoctor1, you still get William Hartnell because he is in the dictionary. But if you say getDoctor100, then the function will try to get the value out of the dictionary, find it is not there, and then instead return the default, which is don't know. So it means that you'll never get the problem of an unhandled exception coming out of the dictionary, because the only difference is that we now need to we're no longer dealing with a dictionary, we're actually dealing with a func of int to string in our case, and it's now curly brackets, not the square brackets of a dictionary, but otherwise it behaves exactly the same, and it is still fundamentally a dictionary behind the scenes. There. And we can actually take this a little bit further. There's some more fun we can be having with this thing. So let's imagine for a moment that I've got a class called doctor data, which is the thing that gets the data of who plays which doctor. And for some reason, I want to get the first, third, and fifth. Now you could create a new array and call it 3 times, 1, 3, 5. That could be, but we can actually reduce the amount of code noise even further with a few bits of playing around. Well, first off, we could use an indexer. Indexers are cool. So an indexer means that we instantiate a new instance of doctor data, and then we can use square brackets like a dictionary and just call 1, 3, and 5. That's nice. But we can even take this a step further, because did you know you can attach params to indexers? Because you can. You can have an array as an indexer. So what that means is that we can instantiate a new doctor data and call that with the square brackets like an array, and just say 1, 3, 5, And then inside that index, we'll call select, which calls the array function, the array lookup 3 times. And we've reduced that whole thing down just into one rather neat little line, which does exactly what we want. That's neat. That's a handy little tip if you need it. Now, I'm not sure if I've got a couple of videos here. I'm not sure if they're going to work or not. So I've got screen grabs just in case. So let's have a look at a very common scenario, which I still see an awful lot of people doing to this day. Let's imagine for a moment that your boss has asked you to create a function which is going to create a summary of a property of a class, whatever it is. It doesn't really matter, and I don't care. But the point is that you're making some sort of summary. You're going to go get data, check whether there's any data, and then inside, if there is data, then we'll group by what the month and the year, and then whatever prop1 is, it's whatever it is. Maybe it's sales, maybe it doesn't really matter. But the point is I'm going to make an average of prop1, whatever it happens to be, and then go to my data transmitter, maybe that's email or something else, who knows, and then transmit that report. Otherwise, if there was no data, we'll send a different message that said no data. And finally, if any of this caused an exception to occur, we'll log it to the error log. So fine, that's all well and good, except that you sort of swing back in your chair, stick your feet up, and suddenly you look down in your coffee and notice, like that scene in Jurassic Park, it is ripples are appearing in your coffee like that. It's the boss. The boss is back. They are inexplicably large and asking you to do the same exact thing, but now for property 2. So what do we do? What's the easy way of doing this? Well, we'll get to that in a second. First off, think about this. You want to run some unit tests on this thing? Well, fine, we'll do a positive unit test. We've got data, covered those lines. Then we'll cover these lines because now we're doing a test to say there was no data. And now we are running a test to see whether an exception occurred. Well, this is all great. Well, if we make a prop2 report and we do what, no, that video's not going to work. We do what most people do, which is to copy and paste the entire first property report and change prop1 to prop2 and make no other changes. Well, what's the unit test coverage level of this function? You've got 100% unit test coverage on prop1 report. Here, it's actually 0%. You haven't got any test coverage. It is the exact same functionality, so in theory, it should still work just fine, and that's all right. But this sort of approach doesn't really scale up. You've either got to keep copying and pasting all the unit tests, or you don't really have any unit test coverage. You don't know who's messing with any of these reports. And the other thing is that if you are copying and pasting every time, you're blindly trusting the previous person to have produced good code. Then I worked for a system once where there was a set of rules which had to be applied to certain calculations every year, and every single year the rules would change, but the old rules had to be maintained in parallel just in case we needed to go back to an old record and rerun the calculations. So fine, every year we would copy the code base, paste it, and make a few changes, and then ship it. And there we go. So the system was pretty old. There's about 15, 20 of these things. And that was fine, except it was my turn to do this job one year. And I thought, this is going to be a pretty simple job. It's just a couple of changes, bam, bam, jobs are good. But I can't help but notice things sometimes. And I noticed that there were bugs. There were bugs in the previous years. They weren't massively show-stopping bugs, but nevertheless they were bugs. And I thought, well, okay, we need to fix these rather than sending sort of duff-looking stuff to the customer. And then I started to get a cold sweat when I thought, how many times has this set of bugs been copied and pasted every time? And it was quite a lot. It was quite a lot. So once I'd noticed the bugs and started fixing them, I then had to go back over every single previous year for quite a few years and correct them all there as well. And when the code base is a little different each time, that can even get a little bit complicated. So what appeared to be a nice, easy saving of time actually turned out to have added to the amount of effort required to maintain, because you've actually got to maintain then every instance of that function every time, and bugs are going to be copied over too. You haven't really, I would argue, saved yourself any time, and you've actually added to the risk to the project. Rather than having one bug in 1 year, you've now got, say, 6 bugs in 6 different years. You've got 6 times as many bugs. It's not really a saving. Now, the answer uh, is, now I don't know what better name to call these things. I'm calling them donut functions. A function with a hole in. I think the technical term is func or something like that, but a function with a hole in it. As in, I'll write one function and put some holes in the bits that are going to change, and then ask for the outside world to supply the missing piece. The video that's not going to work there. So instead of generating a prop1 and a prop2 report, instead, I'll simply write a generate an average report function, which as a parameter takes a func, which takes whatever the data type is, and an integer out, meaning you, the outside world, tell me which integer property you want to go into the report. And then rather than calling average and then x dot prop1, instead I'll reference the selector function and let the outside world determine which. So I only have to write one function to generate reports of averages of any given integer. Now, maybe I want to apply a t generic or something like that. There's all sorts of extra ways I can go to making this more complicated, but provided an integer comes back, it doesn't really matter what happens between that and the source function. There we go. So what it means is you can generate now a public prop1 average and a prop2 average, which simply reference the generic one and fill in the blank of which property we want to select. And that's fine, nothing wrong with that. I could hang my hat on that, but I might even be tempted, depending on, as always, what you're trying to accomplish. I might be tempted, perhaps even to just simply expose the func property parameter and let out whoever is out there beyond the interface select, and then you never need to add another property onto this interface ever again. That's an option. And this is one of these where it depends what you're trying to do. Another place where I might use this sort of approach is Entity Framework. Now, I'm not a particularly big fan of Entity Framework. It has its issues, but amongst them are you need to make sure you wrap a using statement around somewhere where you're instantiating a new instance of your data store, and that's your context. And then you have to make sure you call toArray on whatever query that you've called, because if you don't, and you pass this outside of the using statement, and then try and access properties of the Entity Framework entity outside the using, you'll find that you'll get a great big error because you're now no longer connected to a live data store. So this is a generic way of interfacing with EF to make sure that the using statement is always there and the toArray is always called, because iQueryable is the basic type of your Entity Framework entity representing a database table. So if we turn iQueryable to iQueryable, it means that we're handing out something to the outside world, which can be, which you can have link-like properties, functions attached to, do whatever query it is that you need. And in my case, I've even said, I'm going to make sure there's a generic check against whatever internals data, whatever sensitive data is already filtered. So you don't need to worry about that in this totally imaginary scenario. There's other sorts of security checks you can do. And then if you always reference Entity Framework through query table, then you know it's always safe. You're always going to have toArray applied. And now I might not actually just rethrow an error there in the catch. I'd probably do something more reasonable, but this is just a very simple example. So you can make this more complicated. And it means the more complexity you put into this method, the simpler then you can make the code in the outside world, as long as you keep it generic. So a few more uses for funcs. There we go. This is an example of trying to validate a username. So in my imaginary case, I am taking a username and I'm doing a check to say, is it null or white space? If it is, then return false. Is the length less than 2, return false. Length is greater than 20, return false. Contains the word Justin Bieber, which return false because that's not allowed. And if none of these rules are broken, then we return true. But that's still a lot of repeated code noise, and there are ways of genericizing this. And here we go. A generic validate function which attaches to t now meaning everything, and taking a params, because I can't be bothered to instantiate an array, and make that params of funcs which turn t, whatever t is, into a bool, meaning was it valid or was it not valid, and then call the link method all. Now, link all means that we do whatever is inside the all call, and every single one of these things should return true. And if at any point any of these don't return true, at this point it terminates early and returns false. So this now completely replaces the previous code block, but it's on a lot fewer lines of code, and it's very easy to see what needs to be done to add a new rule in. Just one line, do an X arrow, and then apply whatever your rule is to the X. Sorted. And that, because it was applied with a generic, you can attach this to literally anything and then validate it. Another option, we could do an apply ops, which takes t, whatever t is, and then a series of operations, and then aggregate, takes those operations, applies them one at a time, takes the result of the first one, and then feeds that result into the second one, takes the result of the second one, feeds it into the third, and so on. So this is a replacement for my earlier 2 Fahrenheit conversion, although you can't change type to type with this one. You have to stay same type every single time. I've actually made it decimal, which makes a lot more sense when you've got divides in. Or another option, did you know that so this is a factory looking at the type of t, whatever t is, and then returning a new instance of the appropriate type. Did you know that you can put types in dictionaries? Because you can. You can make the key a type, and then based on the key, you can return a new instance of actually that thing. And then once again, I'm calling toLookup with default, meaning that if I'll generically say this is the type if you have no other idea what on earth you want. If you give me something that's not valid, whether this suits your business logic or not, it's up to you. But you get the idea of what is possible. So how are we doing for time? I might need to skip through this a little quickly. An idea I came across is, so enumerables are interesting. Also, I can't draw. Apologies for that. I really can't. Enumerables are interesting. Enumerables are not really data. Enumerables are pointers to data. They are a description of how to go about getting data. And that's all they are. So they have kind of 2 buttons on them. One button says, get me the current one. And the other button says, move to the next one. So if I had in my case, a very simple array of characters, A, B, C, D, that's what that is. But imagine if I wanted to edit one of those. Now, typically the solution would be call to array or similar, and then you take the old array and alter it into change one item and then return a new enumerable. So what you end up with is 2. It's 2 arrays, in fact, the old one replacing the new one replacing the old one. But what if, instead of simply being characters, those were incredibly complicated functions of some sort? Maybe they are entity framework lookups, or who knows what, some sort of, what if it's very expensive to go through the process of enumerating each item? Well, then that's really a problem. Is there a way then to make an amendment without enumerating? Well, that's the whole point of doing this particular section. So yes, there is. What you could do is create a new enumerable which references the old one, but doesn't actually reference it, but has a gatekeeper that sits in the middle. So I'm going to make a new enumerable which references the first one, but it's got a little gatekeeper thing in that says replace the third item with Z when it comes along. There we go. I called it adjust. So once again, there are 2 arrows here. Notice that. I'm returning back an enumerable again, but this is still keeping the first enumerable in memory. So I'm calling func, and then a func with 2 additional parameters. So it returns a bool, but there are 2 parameters in t, which means the object, and int meaning the position of the object. So I'm giving you 2 options in the outside world to decide whether we're going to replace or not. One is based on the properties of the object, the other is where it is within the enumerable. And then I'm calling .select because select doesn't change the original enumerable. It simply describes a change that should take place at some point in the future, unless you call toArray, in which case you're forcing it to occur now, and I'm not. And I'm calling for each item, I'm calling should replace, I'm passing in the object, that'd be the X normally, and position within the array, and then deciding on whatever should replace returns, whether to call the replacement or return the original object. There we go, two uses. So first one, adjust, says call the original array, and if I, that is the position, is 2, that's A, B, C, 0, 1, 2, if that'd be the C, replace it with a Z. And then the other one is saying if X is equal to C, replace it with Z. Well, both of those are actually doing the same thing. But on the third line, on array C, after calling this array A.adjust again, array A has not changed. And nothing has actually been done. In fact, these 3 lines will execute and pretty much no operation will take place. It's only at the point when you call a for each or call toArray, only at that point will it finally force these adjustments to be made. And again, the original array will not be altered. You'll end up then finally potentially with 3 arrays. It depends. If your later logic never requires you, for example, to use array B, then the functions inside the adjust will never be called. They'll just exist in memory for as long as they're in scope and then be disposed of without being executed. So you might, depending on what you're trying to do as always, save yourself an awful lot of effort if it turns out that one of these things, for logical reasons, isn't needed after all. And that's kind of what it looks like if you call adjust a few times. It basically means there's the enumerator, which is the thing, this is actually the engine under the surface of the enumerable, which sits under the surface and does the enumeration. And then a series of gatekeeper functions, which sit between the enumerator and the final source array. And each one is doing a check to see, should I do a replacement or should I not? Rue, how are we doing for time? Another quick one. Contains consecutive numbers. Spoiler, there are 15 and 16 are consecutive. Oh, 3 minutes overtime. Right, okay, right. I'm not going to go into this then. Let's just skip out. But that's another thing that we can do, and I will skip that last section. So I'll just wrap up quickly then. There is more we can do involving attributes, but that's maybe a question, something for another time. Finally then, apologies for running over. I hope everyone's still being entertained. I have a book coming out if anybody is interested. It's called Functional Programming C#. It's going to be published by O'Reilly. There is a barcode here which you can feel free to scan, which I believe will give you a month or 2 free on the O'Reilly platform. O'Reilly sent me this as a handy little thing to hand around now. Oh, I did forget to put a slide in. My animal has actually been chosen. It's being British. They've chosen for me. It's what do you call a coyote? A coyote, an animal I'm unlikely to ever see in my life. But nevertheless, it's coming out hopefully in September-ish. Oh, a question from the chat, if you would not mind. From Sean Daniels. Sometimes in a critical method, we end up having a number of important logging method. How do you reduce the noise from such method? Number of important log. I don't know what a number of important logging methods. I'm not quite sure what we mean by this. It depends. I mean, how you can genericize these. I mean, is it a logging method that has a lot of parameters? Maybe you could write a function that references the big long log method and handles some of the local stuff that is the same every time for you. I'm not sure. I personally use nlog, which is just log information or log error, which is fairly simple and quiet. Or do you mean that you need to log every single step, in which case maybe, I suppose you could instantiate an object which takes a logger as a parameter, and then maybe you could call methods in it, which then behind the scenes call the logger every time. I'm not sure. This is where I need to know a little more about what it is that you're trying to achieve. Apologies, I can't give you a more thorough. If we were in person, I might come and grab you and have a chat just to see what it is you're trying to do. But please reach out to me on Twitter or similar if I can be of any use to. Oh, hello there.
I guess. Do you guys have more questions?
I do not bite.
There is one question, one more.
Oh, okay.
Let me show it on the screen. Give me 1 second. It's like kind of last minute question.
No worries, no worries. And again, folks, I'm on Twitter. Please reach out to me.
Yeah. Okay. Now here's the question. It's from
EF
Seth.
yeah, yes. EF Core is not my way to go. Why and what do you suggest then rather? I like Dapper personally. I like Dapper. Well, it depends on a few things. If the most important thing in your project is efficiency, I might even just put everything in stored procedures and then run the stored procedure code on the database. That would be a more efficient solution. Alternatively, I'd write Dapper because it's lighter weight and you get back exactly the data you want. One of the several issues I have with EF is it's a little data hungry, and it's kind of like an energetic dog that is always trying to pull on the lead and pull more data down from the server. If you don't stop it, by default it tends to slurp down more data than you expect. That's one of the things I don't like about it. So Dapper only pulls down precisely what you ask for, and I like that. Alternative, like I said, store procedures in databases. Those are good too. And you can just reference them directly and get the data pulled down, and possibly via Dapper. That's also acceptable. So I go with as lighter weight as possible and making the query match as close as possible to what I actually need in code. That's what I like. It means a little more work up front because, obviously EF has that lovely thing of just like feed it a database, get out something usable, but I think it's a sacrifice I'm happy with. So I hope that answered the question. Are there any more questions?
Okay. I didn't see more questions from the chat bot, so I guess that's it.
Hey.
Thank you very much, Simon. I think you did a great job.
Thank you. That's
very
much appreciated.
Nice presentation. Yeah. And so right now we're gonna have a lunch break. If you already see the schedule, we're gonna have like 1.5 hours for the break time. By the way, hi everyone, I'm Ru. I didn't introduce and show my face earlier. So I'm the moderator in this Track to Line. And I hope all you enjoyed the talks from previous talks from Melissa and right now Simon. So, by the way, I want to remind you, if you didn't check our sponsor rooms yet, maybe you can go knock their doors. They are all waiting for you at during the lunch break time. You can maybe have some talks. And also you can try, I really suggest you to try the fun features like the 90 seconds screenshot and 90-second match and photo booth. You can try the fun features and take some cool photos from there in the sponsors room. So it's like a bit break from the conference content. And don't forget to tag us on social media if you use if you took photos, and you could use the conference hashtag abp.conf23 when you post your photos. All right, that's all for now. Thanks for joining us with the 2 talks, and we'll be back with more great sessions later after the lunch break.
Have fun, folks.
All right.
Eat well.
Yeah.
I'm having noodles.
Also, see you, Simon.
Bye.
Bye, guys.